Greetings, ladies and gentlemen. This is my research project, my ongoing research project, namely steam activated carbon from coconut-based self-sustained carbonization biochar for gas emission treatment. And this is my video presentation. This is our research objectives for this project. First, to characterize coconut-based shell-enhanced biochar produced from self-sustained carbonization technology. Second, to evaluate and characterize activated carbon derived from coconut-based shell-enhanced biochar produced at different activation temperature and time by using steam activation. Third, to evaluate the effectiveness of activated carbon derived from coconut-based shell-enhanced biochar as an air filter media in the gas emission treatment system in terms of carbon dioxide, carbon monoxide, and hydrocarbon efficiency. The research novelty of this project is as follows. First, we change the raw coconut shell and husk into biochar by using self-sustained carbonization. From self-sustained carbonization biochar, which derive from coconut shell and coconut husks, we activate them by using steam, which eventually producing the activated carbon. And from the activated carbon, we apply the activated carbon, which derived from the self-sustained carbonization biochar for the gas emission treatment. This is the research methodology to carry out self-sustained carbonization. To carry out self-sustained carbonization process, we use pilot scale brick reactor. This is a process flow to carry out self-sustained carbonization process. First, form a layer of initiator. Then, put the selected biomass on the top of the initiator. Close the tray. Initiate combustion. Stabilize combustion. And then close every part of the pilot scale reactor. And this is where the self-sustained carbonization process occurs. After a certain period of time, collect the biochar sample and dry and wet them for the biochar yield calculation. This is the process flow to characterize the coconut shell and husk biomass sample. First, we collect from the source, then grind, sieving, drying, sampling, and characterization. Similar process flow was carried out to characterize the coconut shell and husk biochar sample. Collect from the sources. This time it's a self-sustained carbonization biochar. Grind, sieve, dry, sample, and characterize. characterization. Characterize the sample. We use thermogravimetric analyzer for proximate analysis, elemental analyzer for ultimate analysis, FTIR spectroscopy for surface functional group, and scanning electron microscope for SEM images. This is the result of the characterization of raw coconut shell and husks. For proximate analysis, it was found out that coconut shell and husks biomass contain relatively high volatile matter and low fixed carbon. And as for the ultimate analysis, the carbon and hydrogen is relatively high, whereas and they contain low concentration amount of sulfur. This is the BET result for both coconut shell and husks biomass. For the surface area, the BET surface area for coconut shell biomass and coconut husks biomass is very small, and the pore volume is very small, but they have a wide pore, but they have a relatively large pore diameter. This is a Fourier transform infrared spectroscopy results for coconut shell biomass and coconut husks biomass. Here, both coconut shell and husks biomass contain hydroxyl groups on alcohol. And for the coconut shell, they have stretching COC groups, aryl ethers on alkenes, alcohols, phenols, and ethers. And the coconut shell biomass also contain the bending phenolic CO associated lignin on alkanes, alcohols, phenols, and ether. As for the coconut husks, it has stretching CC double on aromatic compound and stretching COC bond. These are the SEM images of coconut shell and husks biomass. For figure A and B, it can be observed that the coconut shell biomass have lack of porosity. Similar characteristics can be shown for the coconut husks biomass. After performing self-sustained carbonization process on coconut shell and husks biomass, the coconut shell and husks biomass were transformed into coconut shell and husks biochar. In this process, self-sustained carbonization have yielded about 22 to 26% of biochar yield, coconut shell biochar yield, whereas and also 10 to 12% coconut husks biochar yield. These are the proximate characteristics and elemental composition of coconut shell and husks biochar. For the proximate analysis, the coconut shell and husks biochar contain high fixed carbon and low volatile matter and a considerable amount of ash. on the biochar. As for the ultimate analysis, as for the elemental composition, it can be observed that the oxygen content is high for both coconut shell and husk biochar. These are the band characteristics for coconut shell and husk biochar. It can be seen that the surface area is slightly decreased in comparison to coconut husk shell and husk biomass. Coconut shell biochar contain hydroxyl groups, CC double bond and CO bond, whereas coconut husk biochar it contains stretching hydroxyl group on alcohol, stretching C double bond O CO double bond, stretching CC double bond, and bending OH group series. The SEM images for coconut shell and coconut husk biochar indicates that there is the porosity on the surface of both coconut shell and coconut husk biochar. After performing self-sustained carbonization to produce biochar, this biochar were used or was subjected to steam activation process. This process can be carried out by using a steam activation process system, which consists of an electrical steam generator, air compressor, stainless steel reactor, which is surrounded by the brick layer, thermocouple 1 that is used to measure the temperature of the sample during the steam activation process, thermocouple 2 that were used to measure the temperature of the reactor, the third thermocouple is to indicate the steam activation temperature. The fire nozzle, the clamp, and also the propane gas. This is the structure of steam activation process system. It is basically consists of reactor system and also the steam generator, which are connected by a steam pipeline. This is the structure of the reactor system inside the steam activation process system. This table contains the description and the function and the statement of functions regarding the component that has been identified in a reactor system inside the steam activation process system. There are basically three phases of steam activation process. First, pre-steam activation phase, whereby the air compressor was used to saturate air inside the reactor, and steam generator, whereby the water chamber, which is a part of this electrical steam generator, was filled with water. This one, and this, and also the reactor system. This is where the coconut shell and husk biochar was inserted into the stainless steel reactor, which is a part of the steam activation process system. The second phase is the steam activation phase. This is where the steam activation temperature was manipulated to 6, 7, 8, 900 degrees Celsius during the steam activation system, and the activation time also varied from 30, 60, 90 to 120 minutes. Lastly, post-steam activation phase. This is where the activated carbon from coconut shell and husk biochar were collected. This is These are the steps to measure the performance or to evaluate the performance of activated carbon as air filter media. This